Features are properties of the data, like the number of points, the number of paths, the width of the drawing, the height, and so on. Let's extract some of these from our samples and feature them on a chart. Get it? Because feature is also a verb that means to, no, I'm not done yet, please, no. Oh, okay. Good, because I should still say that if you plan to follow along, make sure you have the code from last time. Otherwise, get it from GitHub and check the README file for how to set it up.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
We're gonna implement functions to extract features from these samples in a file in Common. We're gonna call this file features.js, and we'll add these functions to an object called features, like so. First function will be to get the path count from the given paths. It's a really simple one. We just return here how many paths there are by outputting the length of the array. And another simple function will be to get the point count from the given paths. To do this, we're going to flatten the array of paths first. This just converts the array of points into one big array of points with all of them, and then we return points.length as before. We need to export this since we're working with Node, but because we're going to use this in the web applications as well, I'm going to check if module exists before that. Let's save this file and move to the Node directory where we're going to create our feature extraction script. Let's create a new file here called featureextractor.js and begin by including the constants from common constants.js. And I'm going to include also the features file that we just created. Now I'm going to use the file system and begin by reading the samples. I'll do this in one line here by parsing whatever is inside the samples file. And then to extract the features, we are going to loop through all of the samples. And from each sample, we will get the paths by parsing whatever is inside the JSON file containing the paths, identified by the sample ID.json. I'm going to create the data point now, consisting of two feature values, the path count and the point count. But because we can have many features, I'm going to use an array here. Then we don't need to worry about x, y, z, and so on. So I'm going to type sample.point. I'm going to add this information to the sample and say an array with get path count from the paths and get point count from the paths, like so. Let me close this for loop. And before we can write this to a features file, I'm going to also mention here what are the names we want these features to have. Path count, point count. And now I'm going to write all this information in a new file. We have to implement this constant soon. And I'm going to stringify a new object with the feature names and the samples. I just combined both of them in one file. Let's save this and define this constant next. So I'm going to constants, and under these samples here, I'm going to write features. Also in the dataset directory, another file called features.json. Let's save this file, go to our terminal and type node feature extractor.js. And this one ends quite quickly. I won't need a progress indicator for it, but I will go up here and write a log saying extracting features so I know it's happening. And at the bottom, I will just output done. Now let's have a look in our dataset features to see how they look like. We can see the feature names as the first attribute and the samples, which is pretty much the same as samples.json, but also the point value here as well. Now, strictly speaking, a feature file wouldn't contain things like this. They are kind of extra, maybe this ID as well. And that's okay, we can exclude them if really needed. We can type here samples, remap them, given a sample S, we will remap it to be an object containing just the point and just the label. Like this. If I rerun the script, we have just this now. But for convenience, I'm also going to keep the previous version with all the data combined. It will help when building the web applications. I'm going to go to constants, and here at the end, I will define a new file path for another JavaScript file, which will hold this information again as a JavaScript object in a JavaScript file. Let's save this, and in our feature extractor at the end, I'm going to write in this new file features_js. I'll start a template literal, so I'm using a backtick. In this way I can write on multiple lines, and I can also include the value coming from the feature names and the samples as JSON. So here I'm including everything, not just the point and the label. Let me close this and the backtick and this function call. I'll save the file, rerun the script. And now in JavaScript objects here, we can see features.js as well, which is the same thing from previously, but assigned to a features object. We'll update the web application first for viewing the data, our web viewer. And the first thing we do here is say that we want to use this features.js file instead of the samples.js. And since it has everything as the samples.js and more, we can take out the samples from there, and our code here will still work. We can also take out the feature names now from the features global value in features.js. I'm going to save this, and if we refresh this, the code still works. But now if I'm going to open the console here and type feature names, they are here. And if I'm going to look at the samples, they contain some additional information like the feature values here in the point. These points are what we're going to visualize next using a Google chart. And yeah, I know I said no libraries, but this is a temporary thing. You'll see. We'll display the chart in a new div called chart container. And Google Charts expect first here some options. I'm going to start to define these options in an object. The width, for example, 400 pixels. The height. Now the horizontal axis title will be coming from feature names of 0, and the vertical axis title comes from feature names of 1. I'm going to remove the legend because I think it takes too much space, and my screen size here is limited. And I will load the most recent version of the core chart package, like this. Now, this load expects a callback. It's not going to happen instantly. And we can write that here, like so. And we can generate the data in a form that Google likes. So let's put here a new data table with two columns. One for the first feature value, a number, and we'll write here the feature names of 0. And another column will hold another number for feature names of 1. These are not the actual values. The values go here in add rows, where we take all the samples and we remap them to keep just the point value. This will work. We can create the chart now using the Google visualization scatter chart. Where we call draw with the data and the options right here. Now, if I'm going to save this and refresh the page, it takes a while, but eventually we have it here. And wow, we can see now some drawings have like 200 paths and 15,000 points. This is amazing. I don't think mine have something like that. I'm really curious to see which these are from the data. We'll get to that. But first, let's see if we can zoom into this place. I want to investigate even deeper. And by default, this won't let me unless I go here and add a few more options. Like Explorer, Actions, Drag to Zoom. If I refresh, I can now zoom in by drawing this kind of region with the mouse. To zoom out, you need to add something more. It will happen on right click, and we can do that here. Right click, reset. As far as I know, it's the only way possible. And once you zoom in, you can now zoom back to the very beginning, which is a little bit inconvenient because maybe you want to zoom out only a little bit, but you can't. And another problem is I can't zoom in deep enough. I need to pass something more here, max zoom in value of 0.01. This will be enough for our needs. And now I can zoom in very deep, like so. We can also use different colors, one for each class. I'm going to go here and show you how to do that. We are going to add another column, which is going to be used for styling. It's going to be a string with the role of styling. But because we have now 3 columns here, our point has just 2 values. We need to do something about it. So I'm going to generate here a new array, and then I go inside it. And first thing I do is spread the point value of the sample into 2 different values. And then the third value will be a style that we will need to define. I'll define these in utils and one for each label. Let's save this, go to utils.js in common, and implement the styles here at the top. Let's say the car should be gray, the fish red, house yellow, the tree green, bicycle cyan, guitar blue, pencil magenta, and the clock light gray. These are all primary-ish colors, and then dark gray, light gray. These should be okay. Let's save this, refresh, And now you see these different colors right here. Wow. But one thing I really wanted to have here is transparency. It gives an idea of the density in different parts. Unfortunately, this wasn't as easy as I thought. You can't just put here colors with alpha values, it won't work. But what did work is to use a slightly different version of the Google chart, a different library which they call the materials charts, which supports transparency as well. To do that, you have to replace here core chart with scatter in our case, or you can add that one as well if you want to support both. And this bottom part right here will be a little bit different. Let me just comment it out for reference so you can see what changes. And here you type chart, Google Charts. Scatter this time, so it's a little bit different. And here we draw the data. And now we need to convert these options in a new format. Luckily, Google has an option for this. Convert options from options to these new form that the new version of the charts expects. Now we save this, refresh, and it looks a little bit different, and transparency is here. But unfortunately, a lot of things are not. I can't zoom in anymore. I don't have the colors there. And there is no support for this. So I can either choose one chart variant or another one. And I prefer the previous one, actually. But to get the best of both worlds and more, I'll teach you how to build a chart ourselves. Now, it's a big project, so I'll do it in the next video. I don't want it to distract from what we learned today. But I still want to show you the end result. So if you're following along, get the future chart code from the link in the description, and let's add it to our project. I'm going to go here in the web and create a new folder, chart, and here I'm going to add the chart code. We'll only need the JavaScript files here, so I'm going to remove these other ones. So they are these files right here. Now we can remove the Google chart from here and replace it with our own script from chart.js, and we'll need to add the other two ones as well. The one for the chart graphics and the one for the math. Now here the options I tried to simplify a little bit. All my charts are usually square in aspect ratio, so I just put here size, and the other ones I replaced with axes labels, just the feature names directly, and then the styles I passed those from utils, like so. And this part we can remove and define our chart using chart is equal to new chart on the chart container showing the samples with these options, like so. I'm going to save this, refresh the page, and this is our version. We can zoom in, we can drag. The transparency is not exactly what I wanted, so I'm going to pass here to the options this transparency, and let's set it to a low value. It looks like there are a lot of points here overlapping, and I need a low transparency to be able to see them. Refresh, and the data is really dense here. You can clearly see that now. But we can do more stylistic changes. I'm gonna go to utils and change these colors into an object. I'm going to add here for each of them a color attribute, and that's because here we can also add a text field where I'm going to add emojis one by one. Now, before we try this text, let's see how the colors look. And I think because the contrast is not so strong with the colors, I want to set the transparency to 0.7. Yeah. And to get the text appearing there, the emojis, we can type here icon text. So now we get these emojis here instead of the colors, which are quite good because it means that we can see what these points represent without having a need for labels on the side. Labels make your eyes go always to the side to see what something is. And colors on their own are problematic to many people who have trouble distinguishing them. I think this is a good idea, but we could combine the colors with these shapes to make something more interesting. So that's why there is support here also for the image, where we generate the images for these different objects according to this text right here and the specified color. I will generate these images by typing graphics generate images for these styles defined in utils. Now I refresh, and you may see nothing here at first, but if you're gonna drag your mouse over this, they will appear. And now the colors of these different shapes are depending on the colors specified in utils right here. Now our chart supports another parameter here, a callback function for what to do when selecting an item. We'll use this to identify it in the table below. Let's call this function handle click, and we'll implement it in display.js. At the bottom here, the handle click function, given a sample, it's going to get the element by ID of sample and the sample ID with an underscore in between. So this is how we defined these IDs to be up here. And then it's going to add a class to this item called emphasize. Let's save this file, and in styles CSS, I'm going to implement this emphasize class where I just set the background color to yellow. Let's save everything, refresh, and now when we click on something like this car, the item should be also emphasized somewhere in this very long list. Aha, it took a while, but here it is. So this is the car with the most number of points, Claudius' car. Ah, I see, it's because of all this shading. Claudio really took drawing seriously here. But let's make it next so we don't have to scroll through this list. It's going to work automatically. We go back to display.js, and after we emphasize, we write here scroll into view for that element with an auto behavior. You can also try smooth, but I like things to happen fast. And block center will make it scroll to be in the middle of the page. Let's close this. Save the file, refresh, and now if we press the car, we immediately jump to Claudius' car. And if I'm gonna go back up, let's check this house. This is amazing. Claudio has both items with the most number of points. And we also see a problem here. We shouldn't have two emphasized items anymore. Let's fix this. I'm going to take all the emphasized items in an array like this, and then for each item in this array, for each element E, we are going to remove the emphasize class. Let's save, refresh. Now I click the car, now I go up and I click the house. works, but I don't want to go up all the time. I need to select something new. Let's have the chart on the side and the other content on the left. And the chart will not move on scroll. I'll first go to Styles CSS and make our container to have a width calculated from the 100% minus the width of the chart of 400%, like this. Make sure you have these spaces here, they're important. I'm gonna save this, refresh, and if I'm gonna zoom out a bit, you can see this space here. This is where the chart is gonna be. Back to CSS, we can define here the style for chart container. Position will be fixed, right will be 0, top will be 50%, and this will just make its top part to be in the middle. I want it to be in the middle. So we translate nothing horizontally, but by minus 50% of its height vertically. Let's save this, refresh, and now if I'm going to press these items, I don't need to scroll back to the chart anymore. I would also like to have selection happen the other way around, like clicking on these items. To do that, we go to display.js at the top here and add our click handler also to the sample container. Like so. And if we refresh and click this fish, it selects it, but it also moves it here in the middle of the screen. And I don't want this behavior when I'm clicking in the table itself. I do want it for the chart, but not here. So let's specify here a parameter set to false. It's gonna be do scroll true by default, but only if true, it's going to do this scroll into view section here. Let's save, refresh, and now clicking on these things emphasizes them as well, but not yet on the chart. For that, we need to go back here and say chart, select sample, sample. We can save this, refresh, and now we can see where this fish is in the feature space. This is a nice fish, by the way. Wow, and James drew a Christmas tree. I didn't think about doing something like that. Now, there's actually one problem here that causes an error. If I'm gonna click here in the empty space to select nothing, this handle click now breaks because sample is null. So we need to take care of this. Here at the top, I'm going to do a quick check. If sample is null, then let's just de-emphasize everything just in case. And I'm going to return. This breaks because we are trying to access its ID here. We can also deselect the sample by clicking on it again. So we can check here if the element is already emphasized, the one that we clicked on, no matter in the chart or in the list. We are going to remove the emphasized class from it. We're also going to tell the chart to select nothing if we clicked on this from the list on the left. And then we return. We don't want to disturb the functionality when we're actually selecting something here, which still needs this de-emphasize code from previously. Like so. Let's save this, refresh, and now if we click here, no error. If I'm gonna click on the house, it's going to select it. If I'm gonna click outside here, it will deselect it, both from here and from the list. If I'll click this bicycle, it will select it both here and there. If I'm gonna click on it again, it will deselect it. And the same deselection happens if we click on it again here on the chart. So this is now the full chart functionality done. Let's test bigger. I think we can have a little bit larger chart here. So in viewer HTML, I'm going to set this to maybe 500, save. Style CSS, we also have to subtract here 500 and save. Let's refresh. Yeah, I like this. Let's see what this tree is here. It has so many paths. Ah, okay. Daniel here drew it so that it has many branches. 200 something branches. Wow. Actually, I think there's detail also here. Really nice. Let's see what else is here. Wow, okay. Nikoni has these drawings here with a lot of content. These will be tough. Wow, such a nice car here. So much detail. Aime must have spent a lot of time on this. Herminio's bicycle also has many points. Same kind of style here with the shading. Actually, Nikoni seems to use it too. Having a fast, responsive system like this is a huge help when you inspect your data. Otherwise, you'd have to do a lot of manual work, like maybe get the ID somehow and look for it in the files. It's slow and mistakes can happen. Try working smart all the time and avoid silly mistakes like that. Did you follow along? Great. Please like this video if you learned something today and share it with others so they can learn as well. And if you got stuck somewhere, ask and we'll figure it out. You can also take my version from GitHub and compare. Can you extract two other features from the samples and show them on the chart? If you need inspiration, you can watch my older video here. It also teaches how to extract features from the pixels, something we'll do a bit later. Now, when you're done, look at the structure. Is it any better? Useful features should group together samples of the same type. Share your code and screenshots with me, and I'll include the best ones in a future video. Next time, we'll implement the chart.